Good afternoon. My name is Tran, and I'm the lead of the optimizer team at Vertica. So today I'm going to talk about 3 generations of Vertica Query Optimizer. Okay, so because of the time limit, so I'm focused on 2 points. The first one is the lessons we have with our experience, and the second is our challenges. Vertica Query Optimizer went through 3 generations. We call it Start Up, Starify Up, and V2 Up. So also because of the time limit, I won't explain why we do this, and I won't explain the picture. In the first startup generation, there are 2 major assumptions. The first one is the analytic schema would be a star or snowflake schema, and the queries will include at most 2 very big tables whose data needs to be segmented, and many small tables. But in reality, our customer schema are not snowflakes, and their queries include many big tables that need to be segmented. So that's why we come up with a second generation. We starify all of the query, so bring it into snowflake queries, and we apply distribution and sort algorithm after joint enumerations. So we have quite reasonable performance, but we knew we could do better. So that's why we need to come up with the third generation. We call it V2 Up. And with this one, we have many goals. The first one is this query optimizer will support any kind of schema. It will be property-aware optimizer, and it will explore only a feasible blend search space, and it will have more sophisticated cost model. And another important one is we try to avoid to redesign another major generation. So we think it should be fully extensible for ongoing improvement and future big data requirement. So with those in mind, we design our optimizer as an extensible modular optimizer. We choose projections and rank joins based on categorizing and classifying the physical properties. And each physical property could belong to a module, and the degree of importance of each module can be different, can be adjusted easily by developers. And actually, we choose the degree of importance of each module based on the actual, our actual customer queries and data. We also prune the plans using our cost model. So with that design, we do not have to, we do control the search space, but we do explore the optimal query. And for the future unknown requirements, if there's a property, we need to add a property, we just need to add a module, or with a property become prominent, we would change the degree of importance of that module. So the V2 Up does choose better queries generated by startup. So like other database, Vertica also run into have challenges. Every time we improve the cost models, even though we do a lot of experiments on customer data and our in-house databases, we still know that 95% of the queries will get better plans, but 1% of the queries will get worse. So so the question is, how can we avoid it? How do we know if the performance that performance come from Query Optimizer or somewhere else, or can we bring back the blend from previous version to the current version? So with that, I conclude my talk, and I have other numbers and experiments number and the joint algorithms. If you have questions, please come to the poster. Thank you.